Today I'm going to discuss about another important topic, which is what is centripetal acceleration. Now, what is centripetal acceleration? Just we have deal with the normal acceleration, which is perpendicular to the tangential acceleration. Now, what is centripetal acceleration? Centripetal acceleration. The acceleration of a body in a circular path, we have just deal with it. The centripetal acceleration, the acceleration which is responsible for keeping body in a circular path. For example, consider this body here. This is a body. Now we know that what's happening right now. I'm just gonna bring this here for a while. Okay, I've brought it here. So let's take a marker for explaining it. We know that this is a point that the previous thing that I'm repeating again. So this is our tangent point, and from tangent point velocity vector is drawn here from VT velocity tangential velocity vector, and tangential velocity vector is here. And the other important thing is that if acceleration, tangential acceleration, this is tangential acceleration, which is this is a velocity vector. Tangential velocity is also a tangential velocity. This is tangential acceleration, which is at, and then this is an, which means that normal acceleration, tangential acceleration, normal acceleration are perpendicular to each other. So this is normal acceleration is now known as centripetal acceleration. We have deal with it as tangential acceleration is a sine theta, which is responsible for providing the direction to a body. So this tangential acceleration is now here, not tangential, I'm so sorry, normal acceleration responsible for providing the direction to a body. So this normal acceleration is now known as centripetal acceleration or a radial acceleration. This is now the actual name of this acceleration is centripetal acceleration, which is responsible for keeping body in a circular path. For a while, the condition that we need to understand is that for by dealing or driving the formula of centripetal acceleration, we know that we will consider the tangential acceleration is equals to 0, which means the velocity. Wait, where is the bar? Where is the bar? Where is the bar? I want to find it. Where is the bar? So let's. I'm unable to find in my keyboard where the bar. Provide some zero, something like this. Okay, have gotten. So now I'm gonna write velocity, and then again, then which means the velocity of a body is equals to constant, which means the acceleration is 0. Here the body is moving with a constant constant velocity. Magnitude of the speed is constant. This is also a point of velocity vector. And now we can see that here the force is applied in two components, something like this. The same history will repeat, or same phenomena will be repeated throughout the circle. Then again, this is something like this. So this phenomena will be same throughout the circle. So erase it. Let's erase it and let's deal with it. Other important path. For a while, consider that this is a circle. Now I will gonna do the complete derivation like this, complete based upon this triangle formula and all that. So for a while, consider that this is a point. Here is the velocity vector v, which is drawn something like this. Velocity, tangential velocity vt, or we can call it v1 and v2 as well. Another tangential velocity which is drawn something like this. V naught. I'm calling it as v naught. Okay, from here I have drawn a 2 point. This is 1 point here and 1 point here, and I have drawn a 2.2 lines, something joining this from the center, something like this. So we know that the distance from a center of a circular boundary is equal. The radial distance or the position vector is equal. So I can call it as r vector, or I can and this is known as r naught vector. This is known as r naught vector, and the angle here is delta theta. Delta theta. Now the line is drawn from here to here, something like this, and which is delta r. This is a line delta r. For a while now, I'm going to bring this two velocity vector here, and I'm going to make a new triangle here. So let's change the color so it will be prominent for you. Okay, I've taken this velocity vector here. This is v velocity vector, and then again one more velocity vector, which is something like this. This is something like this. Right. V velocity or v naught velocity. V naught. Now drawing a line from here to here, which is delta v in nature. Since when you're gonna move this vector, which is this vector is drawing from this point, consider this point is fused with this point. So when you're gonna move it, this r vector will move as well. Same for it. When you're gonna move this v naught vector, this r vector will move as well. While their delta theta, this is delta and theta will remain same. So here the delta theta will also remain same. Delta theta, this is theta 1 and this is also, don't need to give a theta 1 or theta 2, this is also theta, this is also theta, this is theta, and this is also theta. Since the theta is same, so I can call this triangle as, let's take a new color in dark color. For example, this triangle is O P Q, right? O P Q, and this triangle is O dash P dash Q dash. So the triangle is equal, which means triangle OPQ is equals to O triangle O dash, P dash and Q dash. Let's move a little down for explaining the further formula. So O dash, P dash and Q dash. Now what I'm gonna write here is that since we know that the radius distance is same and the velocity distance is same, so I'm gonna write here the magnitude of the velocity, magnitude of the r, the magnitude magnitude of r vector divided by r magnitude delta r divided by r is equals to, or I'm going to write it with the help of marker because then it will not be clear that what I'm writing or what I'm supposed to write here. I can say that the vector here, for a while let me confirm the formula. So yeah, I'm going right, I'm absolutely going right. So here what I'm going to write here, where's the marker? Yes, it's right here. So what we're going to do here, I'm going to write here that the magnitude of the r vector, delta r vector divided by magnitude of r vector, then it's equals to magnitude of v vector, this is theta, magnitude of v vector divided by v vector, dividing time on delta t on both sides. Now I'm writing dividing delta t on both sided, and then something like this, then magnitude of r vector divided by magnitude of r vector divided by delta t is equals to magnitude of v vector divided by v vector and then delta t. Now we know that the delta r upon delta t, we are aware of this formula, delta r upon delta t is equals to, yes, it's equals to velocity. Delta t upon delta r upon delta t is equals to velocity. Now let's move here. Let's change the color. It is equals to v vector, right, and v upon r. Now we know that the what is velocity upon time. Change in velocity upon change in time is equals to acceleration, a vector or acceleration, and then velocity is remaining. Multiplying velocity with velocity, so centripetal acceleration, which is equals to v square divided by r. But this is a formula of linear centripetal acceleration. What is the formula of angular centripetal acceleration? We know that the v is equals to omega r. So taking the square of the omega r to be something like this. Omega का square upon r square and then multiply by r. Since r cancel r and the formula will be, let's move a little down. The formula of centripetal acceleration of the angular quantity is omega square r. So this is the formula of centripetal acceleration. So yeah, if you want to know the overall acceleration, you can easily find it by taking a vector is equals to magnitude of square, then magnitude of what? Magnitude of an का whole square plus tangential velocity whole square. This is the overall way of finding out the acceleration.